Hey team, it's Mr. Z, and today we're going to look at solutions of quadratics and analyze why we use y equals 0 to help us solve equations. Let's go ahead and dive on in. All right, so here I have a quadratic in factored form, and I'm going to go ahead and test out why we have to set out f of x to be equal to 0, which is the same thing as saying y is equal to 0 to solve. Making the substitution, it reveals that I have the product of two substances, here and here. So the idea behind this is for the answer of the product to be 0, either the yellow group or the green group have to have a value of 0. This x minus 9 must be equal to 0. This x plus 2 has to be equal to 0. Now I use my inverse operations to solve, and it reveals that when x is 9, and when I use inverses, it reveals x is equal to negative 2. So what this means, and to help build what we found, we are going to check our solutions. I'm going to demonstrate why 9 is a solution. For this function, if I plug in the value of 9, it is going to result in being a number minus 9. I go ahead and substitute it in and look to see what happens as I evaluate. It becomes 0 times 11, which is 0, meaning that the solution is correct. Let me do this again for f of negative 2. I'm going to have it set up a specific spot, negative 2 minus 9 times negative 2 minus plus 2. And with a little foresight, you can visualize that it turns into the product of negative 11 times 0. Notice how the solution for the left, 9, makes this group 0, resulting in my product that I desire. Notice that when f is negative 2, it is also still 0. Notice the product on the right is negative 2, and it still becomes 0, but from the right side. This is why we have two solutions. It is to the second degree. In addition, there are two opportunities for the value to be 0. So these are solutions because the equation is balanced. It does reach 0. The reason why I also call these solutions the zeros is, 1, because the technique is we're using 0 to solve it. And also, if I represent these solutions as a coordinate point, as a x, y, it reveals that 9, okay, what's the answer when I plug in 9? 0. What's the answer when I plug in negative 2? 0. If I just visualize using a graph, 9 to the right, 0 up and down, negative 2 to the left, 0 up and down. Notice how these are both x-intercepts. This is why factored form is phenomenal for identifying x-intercepts. But remember, you can't just look at this function, f of x is equal to x minus 9 times x plus 2. The big thing is some students, they haven't had the experience yet, and they might be saying, well, I got this. X is going to be negative 9, and x is equal to positive 2. Let me show you why this is not the case. So I'm going to go ahead and set this to be 0, and I'm going to substitute in negative 9. I substituted in for all of my x values. I clean up, and notice what happens. We do not have a product. This is not going to be a product of 0. Negative 18 times negative 7 is not 0, meaning this is not a balanced solution. Notice how much of a difference the positive and the negative sign has an impact on the output. If I repeat this for, let's just say, the other solution, x equals 2, 0 equals x minus 9 times x plus 2. I plug it in using color for my substitution as a good practice. And it reveals the product of negative 7 times 4, which is definitely not 0. So these points are not equal to 0. These are not the x-intercepts. I hope this reinforces the importance of why we have to look at the standard form, factored form with the reference guide. If I use f of equal to x times x minus 9 times x plus 2 and compare it with the defunct equation x minus root 1, x minus root 2, the zeros, notice how it is just a 9 that is part of it, just a positive 9. Here for root 2, notice how it is not in the form x minus a number. So if I rewrite this part to be x minus minus 2, it then is on site being able to see my other solution is not positive 2, it is negative 2. I use an equivalent expression in order to help see this. Bonus points. A does not have a coefficient. It's an invisible positive 1, meaning this graph is going to be concave up. And since it's concave up, it is going to have a vertex that is a minimum. All right. So this has been a quick tease on why x-intercepts are the way they are. Support visually and support with the graph. That's it for now. Ciao.